been waiting way too long. Yeah, I've been out here trying to get it. Yeah, I've been waiting way too long.
This is the video for Geometry, Chapter 9, Section 3. We're going to be talking about rotations. A rotation is a transformation in which a figure is turned about a fixed point called the center of rotation. We are going to use the origin as our center of rotation for all of our rotations. You could also use, for example, one of the vertices of the polygon that you're rotating or the point that you're rotating. But again, we're going to use the origin. And so what that means is that this is our center of rotation. And so if I want to rotate this triangle 90 degrees, then that means I would be rotating it from here to here. Okay, that would be 90 degrees. Versus if my center of rotation was here, then my rotation would be from here to here. So that's kind of how it's different. And so all you need to know is that we're going to be using the origin as our center of rotation. And what you're going to do is you're going to go in GeoGebra and you're going to work with some of these rotations, and you're going to notice that there is a pattern regarding what happens when you rotate a figure a certain number of degrees if the origin is the center of rotation. The one thing I need to make you think about is if I rotate something 90 degrees, we need to talk about which way I'm rotating, because I can rotate clockwise or counterclockwise. So let's just go with this point here. If I rotate that 90 degrees counterclockwise, okay, counterclockwise would be this way. Clockwise is this way. Okay, so make sure you know the difference. This is counterclockwise and this is clockwise. So if I rotate this 90 degrees counterclockwise, then that's from here to here. And if I rotate it clockwise, it would be from here to here. Now, 90 degrees counterclockwise is the same as, think about it, if I go clockwise, this is 90, this is 180, and this is 270. So 90 degrees counterclockwise is the same as 270 degrees clockwise. In the same way, 270 degrees counterclockwise is the same as 90 degrees clockwise. So you need to make sure you understand that it depends which way you're going, either counter or regular clockwise. Now I'm going to show you kind of just the basics of rotations in GeoGebra. So when you're in GeoGebra, you'll notice this on the handout, but just if you need to refer back to this, you can. You'll want to show the axes and the grid with just the major grid lines. You don't want the minor grid lines. So I'm going to just make a triangle here. All right, so here's my triangle, and I'm going to rotate it with, again, the origin as my center. So I'm going to go down to transform. So you need to plot a point on the origin so that you can use that as the center of rotation. So I'm going to click around on rotate around point. I'm going to click on the polygon, and then I'm going to click on point E. And then it asks me how many degrees in which direction. So let's go with 90 degrees counterclockwise. Click OK, and there is the rotation. So then I want you to see that it's the same if I do 270 clockwise. You see, it's the same thing. It didn't make anything different. So that's how you do rotations. Again, make sure you plot a point at the origin so that you can always rotate your figure around or about the origin. Another quick reminder is that if you need to see the coordinates, when you click on the point on the computer, you'll have an option where it says AA, and that's with the label, and you can click on show value, and it'll give you the coordinates of the point. So again, you don't see that option on the iPad here, but if you click on show value, under the AA option, you will be able to see what the coordinates are. So most of what you're going to learn about rotations is going to be from the GeoGebra assignment, and you're going to want to use that GeoGebra assignment to help you with your practice problems, because you're going to discover some things there that are going to be necessary for you to know as you work the problems.